put in inputs for 4 direct boxes. Now, this is a recommendation, this is a suggestion, and this consumes 15 inputs of the 16 that would be on your stage box. Remember I said be careful about running out? Well, you see that we've already used up to 15 inputs, but you have a lot of flexibility here as to what those 15 inputs are. Then on the output side, we have, starting from the bottom, the main left and right speaker outputs, which goes to a 4-channel amplifier, and then goes to the main left and right speakers and the outdoor left and right speakers. Now, I'm only sending one each left and right channel within the wiring to the input of the amplifier, or even potentially within the amplifier itself. You can configure which outputs these inputs go to. So channels 1 and 2 would be left and right. Channel 3 and 4 can be mono outputs, because these two outside speakers will be mono. You don't want to do stereo on the outside speakers because you only have one in each of your seating areas. Mm-hmm. Going up from here, we have an output that's dedicated to the listening assistance transmitter. And then I allowed for 3 stage mixes. So one goes to a wireless in-ear monitor transmitter, which could just as easily be a loudspeaker. And 2 more for 2 stage wedges with their own amplifier. And again, we said that these amplifiers can live in the rack, or they could actually live inside the speakers.
Okay.
Now, if you have powered loudspeakers, remember that you'll have to provide them with AC power. So you want to make sure that you have electrical outlets nearby and extension cords, in addition to the audio cables that come from the stage box. Mm-hmm. So that's 6 of your 8 outputs, which is sufficient and gives you 2 more outputs that you could use for future use. So I think this 16 by 8 configuration is a suitable size for your application.
Okay.
So here we have the sound mixer down here. And you see that that's connected to the stage box by connections we call AES50, which is what Behringer calls them on the X32. It is nothing more than a shielded Cat5 cable.
Dedicated, okay.
Right, dedicated, shielded Cat5. Does not go through the network. It goes directly between the mixer and the stage box. Stage box and the mixer have another one called AES50B, which can be used if you were going to ever use a second stage box. You would daisy chain from this one to the next one, which is very convenient. The mixer does have an Ethernet connection on it, an Ethernet port on it that would go to your Ethernet switch. And that's so that it can connect to a computer so that you can run software that can actually control the computer from software, or you can save scenes and setups to software, and do many other things with it. There's also a USB connection between the mixer and the computer, and that's where your audio flows. So audio is not flowing through this Ethernet port connection. Audio is flowing through this USB port. And the audio that flows here is completely configurable. You can have actually all of your inputs connected, transporting to the computer individually, so that you can record every input separately. You can configure it to send the mixes out, right? So that's how you would do your streaming mix and get that out to marry to your video computer. Is the streaming mix bus would go out this USB port to the computer. That computer encodes it, sends it to the Ethernet switch. That goes to the video computer, which is on the next diagram. This way, you're not running an analog audio wire from the output of your mixer to some input on your your streaming computer. It's all done digitally through the network.
And what software would be running on that computer to do that encoding?
There's few different options, and I list a couple of them right here. NDI, VBand, and Dante are three good options.
Okay.
And you see, you're sending information, sending audio to the streaming computer, to the video computer, and you're receiving audio from the playback computer and from the video computer. Is if there's something playing back that's video that has audio, that needs to make it into the audio mixer so that people can hear it. So then we'll move on to the video side of the equation of the system. And we'll start at the top here. Here are your three existing cameras. They connect via HDMI into your ATEM Mini Pro video switcher. And you'll see the little lines are your basic HDMI cables. They will need to go into HDMI extenders and then back into standard HDMI to plug into the mixer. And then we have your optional pan-tilt zoom camera, which connects via HDMI the same way into your ATEM switcher. From there, you can connect a video monitor directly to the switcher that has a multi-view output. And what this is, it's a multi-segmented screen, much like your Zoom's gallery view, that shows you all of your video inputs, your still store pictures, and your switched outputs, your preview and your program.
Yeah, we use that.
And then via USB-C, you come out of the mixer into your video computer. And this is where you'll run vMix. And this is where you can do your main streaming from. And what we're showing here is that this computer has two monitors on it.
Okay.
Now the Ethernet port on this computer carries both Ethernet and NDI, which is a video and audio networking technology that allows it to communicate video and audio signals to other devices. This is one way you can get this. If this pan-tilt zoom camera has NDI built into it, you can get that video signal through the switch directly into your vMix computer. So you could have it available two ways. You can have it through your ATEM switcher through hardware. You can also get it through software. This is also how you would get your audio from the audio diagram into vMix is through the NDI or one of the other protocols that we talked about. Then we have your playback computer and your second PC or other computer for other functions. They all get connected to the same Ethernet switch and carry Ethernet and NDI for audio and video. Then I'm showing your two outside video monitors. And I'm showing them here running over NDI, but and your projector too, which is your inside screen. I'm showing them here running NDI, but they could be one of the other protocols as well. So this is a suggestion. This is not necessarily a part of our recommendation. And finally, for the pan-tilt zoom camera, we're showing the camera controller, which also can have a connection, I'm not showing it here, a connection to the Ethernet switch, and that's how you would control it from vMix on this computer. So what do you think of that?
This is quite a bit more than we were anticipating seeing. And so obviously this, in my mind, has to come in through phases. And so maybe one question might be, how would you phase this out
Well, correct me if I'm wrong, but you're already doing at least 80% of this. You already have these cameras, you already have the ATEM, you already have the vMix.
Actually, we don't have vMix, but that was something that we're looking at. Yeah.
Oh, I'm sorry. What are you using then?
Let's see. Right now, that goes straight into Zoom, I believe, from the ATEM.
Oh, you're streaming right out of the ATEM.
Yeah.
Now, I thought I did see computers on a desk, though, right?
They're not, Marty. They're going from. He's saying they're going from the ATEM into the streaming PC, and the streaming PC is running Zoom direct, not using anything, not using a switching software.
Oh, okay. All right then. So you have the computer and you have the ATEM and you have the cameras. And so that's
and correct me if I'm wrong. vMix is not terribly expensive, at least to get started.
Correct. It's only about
not to get
$60
started
at the entry level.
At the entry level, not to get started, but it hooks you in and reels you in quite quickly.
I got it.
And vMix is, one option. There are other options. There's OBS, which is completely free. It is a good starter option.
Mm-hmm.
Yep. So you have everything on this side of the diagram.
Right.
And so, we may be looking at adding a second monitor, a third monitor for multi-view, a couple of less expensive computers for playback and control, and your Ethernet, right?
Yeah, and that's actually, that part's already underway even this week, the Ethernet. I'm worried that they may not have thought about power over Ethernet, although I did mention that would be desirable.
Power over Ethernet at this point, I put this in here because that can power your pan-tilt zoom camera rather than having to power it locally. And, it's always worth getting a decent switch with power over Ethernet because, you never know what you'll be adding. Any kind of small device, many small devices can be run over power over Ethernet and avoid having to worry about little wall wart power supplies and AC strips and, all kinds of wiring. Power over Ethernet is a marvelous thing.
Netgear makes some very affordable little managed switches with PoE on them that do a great job with all of this.
Yeah, you just have to be very conscious of the power budget.
Right.
Yes.
Yeah. It's called PoE Plus. For me, it's called PoE Plus, and that means that this switch will deliver basically the full power wattage to the ports, to 8 of the ports or something like that.
But it's also not terribly expensive to add PoE. There are 4-channel injectors that probably about $30 a channel to add if you need to just want to have a consolidated additional supply for PoE Plus devices. Right.
Yeah, there are a number of different ways to skin the cat. Whatever way you choose, just be very conscious of the power budget of the amount of power that each device needs, and add a safety margin of like 25%. Very important.
So the key thing I think on the video side here that we're looking at, that is maybe, Matt, is where you've got to look at is the bit to the right, which is the projectors and that area is how, because at that, I'm taking a guess that's the bit that's not, I don't remember seeing that in play at the moment. and the projector isn't coming out of the machine, is it, at the moment?
Yeah, we really don't, we're not satisfied with the projector, with the whole concept of projected video in that space. It's just too bright. And so we've been going down this path of screens. You know, I think one big question will be to see how full we get, and whether that exterior seating area becomes such an important space that we have to have screens out there. Now, what we might look at is screens on portable stands, like you were talking about, that really live more in the interior space, at least in the beginning, because that's where the audience is going to be, unless we really swell up again.
The recommendations we made about the exterior screens were based in large part on photographs, so we were making best guesses.
Yeah, sure.
The decision on that will really come down to what are the sight lines actually like from those two outdoor areas looking into the sanctuary, whether or not people feel like they actually need more visibility, things like that. You could do something as simple as just hang a loudspeaker out there to boost the sound outside. And if people can see what they need to see, yeah, you don't have to do that part at all.
Yeah, so that might be the save for later part of this project.
Sure, sure.
And that's easy to scale down or scale up as you need.
Yeah.
And if out of those 3 static cameras, you get everything you need, you get the 3 shots that you need that will make people happy on the far end, don't need to buy a PTZ camera right away. You can wait and do that in another phase. It really comes down to, we designed this around your stated goal. A whole bunch of goals included the stated goal that you anticipate expanding into a larger space. So we were sort of building for that expansion as well.
Yes, I appreciate that. Yeah.
So yes, the comment was made in the chats that this seems like a lot. It is a lot. There's no question. What we came up with was the best of all possible worlds, but this can be chopped up into smaller pieces and accomplished slowly. Certainly.
Yeah, and that's good. I mean, I appreciate the value of not having to chuck a whole bunch of stuff, because we moved to a different location that's bigger.
Right,
right.
Yeah, anything that we're recommending, you're going to be able to take with you. And we did try to use as much of the gear that you already have as possible as well. So
even things like the main loudspeakers, if you move into a substantially larger space, you're not going to be using those as main loudspeakers, but you can repurpose those for other areas.
Use them for fills, the crying room, the minister's office.
Anything would have to go to waste at all.
Right.
Yeah, excellent.
I want to just a real quick touch back on the wireless microphone thing. If you probably the shortest, fastest way to find out what will work, where you will be using them, is the manufacturer's websites for frequency coordination. Generally, I know Shure does this, and I suspect the others do as well. You put in where you are geographically. It will identify your local television stations as points of interference, and it will give you a starting point for frequencies, how many quantities of microphones that will work together. And from that point, the next step would be if anybody else is operating in your same frequency range. And that you could find out with a frequency scan.
And it may not be good news, but if you do buy wireless microphones, Shure sort of has a sweet spot for, you're guaranteed to be in pretty safe territory, both frequency agility and as far as a robust device, it's not, you will not be beaten up. Buying cheap, or rather buying inexpensive wireless rigs means you're going to get cheap wireless rigs. I would recommend, personally, I would say if you can afford it, go to the Shure ULXD series of wireless rigs. They digitally encode and choose subchannels. you get a little bit more security. Not by security, I mean being able to find a frequency that you can live on. And they're good rugged devices. The inexpensive ones, yeah, they're inexpensive for a reason. You get what you pay
when
for.
it comes to wireless microphones,
Buy
you
Pro
really
gear.
want to try and find something that where the body pack transmitters and the handheld transmitters are metal bodies, not plastic. But let me say this. I can't say much, but on June 1st, there's going to be a pretty major announcement from a manufacturer about a new wireless microphone system. Stay tuned.
So don't buy anything yet, Matt.
Okay. At least in that part.
If you can at all
Marty,
avoid it.
Marty, can we,
Yes,
can
sir.
we, I mean, we've just covered the video. Was there anything else on the video side of that map? And could we flip back to the audio quickly before we
No,
wrap
that's
up?
it for video. We can go back to audio here.
There's a couple of questions and things because I missed Sunday, but also for just asking to clarify with Marty as well. The stage box you've listed on the left, you put down the S16 and not the SD16. There's two different models from if he goes down the route with Behringer. Was there a particular reason you took the 16 and not the SD16?
The difference between the S16 and the SD16 is that the S16 is a rack mount unit. The SD16 is a floor box, a stage box. Other than that, they both have 16 inputs and 8 outputs. I use the S16 because it can be rack mounted and it can sit at the front of that rack and you can plug all your instruments and such in right there.
Okay. The only reason the only reason I go with the SD is the SD has inbuilt DI boxes straight in.
That's true. The S16 does not.
And also it has the ability, if he chooses, there is monitoring, although they may have both on there. So that's that.
I don't think there's monitoring on the SD16, only on the S16.
There's whatever Behringer's monitoring thing. I've forgotten what it's
the personal
called.
monitors. Oh, the personal monitors.
Monitors. Yeah.
That's something we didn't get into, but that's an interesting.
And then I'm just covering the hardware side of it rather than going into the deep into the stuff on the actual on the audio side. And the other question, just for Matt, maybe you put in there the what do they call it? The digital, you put in the compact version of the X32.
Right.
And a map, for those out there, there are about 4 different models. And really it's just how much of the sliders are on physically in your view at any one time. Right. So the compact has a combination of half of the 2 sets. If I remember rightly, the producer. I
don't recommend the producer. The producer doesn't have scribble strips. It's missing a whole lot of buttons.
I think the producers are really not worth touching. And the big version, the full X32, basically gives you both your inputs and outputs all in front of you. But I don't think he needs it with the amount of mixing he's going to be doing.
No.
Yeah, for a church his size, the compact is great because you get 8 inputs per layer. I'm guessing that the average service is going to use about 6 inputs.
You can actually actually get 16 on a single layer.
Will it
you
let you span the inputs all the way across?
Yep.
Yes, it will. It will if you hold the buttons down. But I just wanted to cover that really quickly, just so that there was why is that, why which stage box and why which mixer, just so that for those watching, including Matt, because there's a lot of choices out there. There's a lot of choices, and we know we're not just saying it's not that we're saying that you need to go down the Behringer route, but there is a familiarity in the software that you're already doing that you may find it convenient. But if you've got people in your church that are happier with other makes, then that everything will work.
It is
That's all.
probably the most economic choice too.
Thank you.
Okay.
Any other questions? Let's. I'd like to finish this up because we have another
Jay
topic
has
to
some
get
really
to.
cool stuff to talk about.
Yeah, we will pivot.
Maybe
Pivot.
the weeds are deep.
But I do want to
Yes.
make sure.
All right.
I do want to make sure we answer all the questions. Somebody raised. So I just wanted to mention when I was talking about cameras, I mentioned PTZ cameras, and I mentioned pan, tilt, zoom cameras, which are the same thing. That's what PTZ stands for: pan, tilt, zoom.
Right. Pivot time.
Hey, thanks a lot, all of you, for your work on this. This is fantastic, and I hope that the folks in the audience, other than just us, got some benefit out of this. And now my job gets interesting to go sell this.
Yeah. So what
There's
we did
always
not,
that part of it.
Yeah.
So we did not propose. We did not work up a cost estimate because there are too many options and things left to work out yet. There are still a couple of unknown design details, such as how to connect the additional video monitors. But most of it is here, and we're here to answer any questions that you may have,
Excellent.
Less than $1 million.
and a site visit.
Yes.
Always.
$1
Always.
million.
Road
Not
trip.
spare
$1
bedrooms.
million.
All right.
All
Pivot.
right, thank you very
Crystal,
much,
that's a
everybody,
jinx
for all your
moment.
work. So next
Yes.
we're going to talk about acoustics. So acoustics. What can we do with acoustics? Noise. It's like wait a minute. What is going on here?
All right, wait a minute. I'm not, so I'll tell you where I am going. So acoustics are going to be a part of the conversation. But acoustics in and of itself deserves, I think, more attention. I did have a conversation with Marty pre-show about bringing in somebody to talk who works in acoustics. And if there, again, I think that comes down to if there's interest, then that might be an extremely valuable thing to have, because the acoustics part of sound, we can't fix bad acoustics with technology. You might be able to manage to muddle your way through improving things, maybe delivering to some level of performance, but the reality is that acoustics is critical to being able to deliver quality sound, and not just the amplified sound, but even just acoustical performance, even just speech, two people talking in a room. Can you communicate with each other? And communicate includes more than can you just hear. So what I'm going to do is I'm going to share a slide deck, and I'm going to caveat that this is very simple, but I think actually that's probably an advantage for the topic. And if you give me a moment, I shall find my share button so I can share my screen.
Might be next to the sunny button.
Thank you so much. Thank you. Thank you. Tip your server as well. Can everybody see my screen?
Yep.
Okay. So the topic I'm going to go to is it's evaluating sound systems. And there are really 4 fundamental questions, that need to be answered. Is it loud enough? Can everyone hear? Can everyone understand? And will it feed back? And there are interrelationships between those 4 questions. Believe it or not, we have a 5th question to pose, and does it sound good? And it's not necessarily as straightforward an answer, but we'll get there. So the question of is it loud enough really comes, it's an answer that has a dependent, and the answer is how loud does it, or the question is how loud does it need to be? And the answer to how loud it needs to be, that is, it depends. What are you doing with the sound system? What's the program material? What's the noise floor of the room? How noisy should a room be if you're doing worship in the room? So I'm going to deviate from this slide for a moment and go over to another document to talk about how noisy should it be in a room for worship. So what you're looking at right now is this is a table from one of my textbooks, Architectural Acoustics by David Egan. And in this book, this curve, I believe, may have come, not that it's the curve, but the data may have come from ASHRAE, which is the Society of Heating, Air Conditioning, etc. Mechanical engineers, people who put air conditioning systems in buildings. Believe it or not, that's next to having a lack of isolation from exterior noise. The thing that probably creates the most constant noise in a venue is going to be airflow, air turbulence. It moves, it makes noise. So what this document provides is a preferred range of noise criteria for different types of spaces. And spaces where audibility, listening to music or speech, making recordings, we really need exceptionally quiet spaces. So the preferred range of noise criteria, the third column is references something called a noise criteria, and the noise criteria is it's shown as a single factor, an NC20 to an NC30 range. It represents an equivalent sound pressure level, an A-weighted sound pressure level, 30 to 38 dB. So if you're an architect or you're an owner, you're building a building for worship, for theater, for teleconferencing, the preferred range of noise criteria for those spaces is NTC 20 to 30, and the quieter the space, the better it will be. People will not have to be challenged, with their hearing in terms of being able to listen to the signal level that should ideally be well above the noise floor. Notice and forgive me, the highlighting is for some other work that I'm doing related to conference rooms and audio-visual facilities. But if you look at the top table, concert halls, opera houses, broadcasting, recording studios, etc., large auditoriums, for excellent listening conditions, you want to have a preferred range of noise criteria that's below a -20. So I'm going to change my share again, and I'm going to take you over to the screen of my iPad. And what you're looking at right now, I'm just going to lift my iPad up so that you can see it. Whoops, sorry, the screen flipped. I have a microphone connected to my iPad, and I'm running a piece of software called Audio Tools. And Audio Tools is measuring the sound level constantly. What I'm going to do is I'm going to shut up, and I'm going to allow the noise level in the room to decay. So the only things that the microphone should be picking up are the fan in my computer, the fan in my digital workstation, and the wall mount air conditioner. So I'm going to be quiet, and we're going to watch the screen, and we're going to see in real time how we achieve and find that noise level. I went and used the mouse. I'm going to talk again. I froze the screen so that it stopped the analyzer from capturing audio. And what we're looking at is frequency analysis. We're showing the actual sound level in 1 octave wide bands or 1 octave centers. So 32 hertz, 63 hertz, 125, 250, 500, and so on. These are all 1 octave spacings. If you look at the chart on the screen, you'll notice it's skewed from the left-hand side of the screen to the right-hand side of the screen. So what does that tell us? Well, what it says is in a given NC, there's a greater allowance for low frequency noise than high frequency noise. Why is that? Well, the higher frequency noise is going to inhibit speech intelligibility. So that becomes a fairly critical piece in being able to deliver intelligibility to your audience. Now, there are times where you actually want to inhibit intelligibility by inducing noise, and that would be like open plan office spaces where people are in cubicles, and if you don't have noise, masking noise, what tends to happen is that people can tend to understand each other's conversations. So we want to destroy intelligibility so that they don't. When we're working in delivering sound for an audience, we have an entirely different intention. We want to deliver good intelligibility. So what's this telling us? Well, in the upper left-hand corner, it says the NC is 37. I think we're certainly higher than we'd want to be, in an empty house of worship. It's telling us the critical band that's pushing us into the NC 37 is 500 hertz. And on the right-hand side of the screen, it says in decibels, the highest sound level is 44 dB. I can do things like I can move the cursor around and find out where levels are. So that's a representation of ambient noise. That's a way that we measure it. We calibrate the analyzer, and then we go in and make our measurements, and then we know in a finished room what it is. If the room hasn't been constructed yet, that's an opportunity for the architects and the mechanical engineer to design systems and build the room in a way that we isolate the room from external noise, so there's no noise intrusion from room to room. And we don't want any noise in the room generated in the room to intrude into adjacent spaces. What I'm going to do is jump back over to the slideshow. And actually, let me go back for a second, and I'm gonna hit the chart again. So NC 20 to NC 30. 30 is the upper boundary of what we be wanting to design for that type of space. Notice that there are allowable, higher noise levels are generally not an issue, and in fact they're anticipated for certain spaces, but note places like cafeterias and restaurants, it recommends an NC 35 to NC 40. I know it's probably been a long time since most of us been out dining out in a crowded, noisy restaurant. Hopefully it's been a while, because we want to be safe and healthy. But restaurant noise has become a real impediment to people enjoying being out, dining, socializing. Restaurant noise can get in the 80 dB range. And restaurant reviewers these days are often bringing sound level meters, and they're actually including noise measurements in their reviews of restaurants, because it's that big an impediment to being able to enjoy your dining. The other part of it is it's hard to have a conversation with someone in a really noisy restaurant. And coming back to worship, let's back to this. What's the noise floor of the room? What's the recommended noise floor? It depends. So what do we need to do? Maybe that's a good place to start. Is it loud enough? And again, there's sort of another it depends branch on this, because is it loud enough for speech? Well, let's talk about what kind of sound level we want to have above the noise floor for speech intelligibility. We probably want to have at least speech coming from the sound system to every listener to be at least 15 dB above the noise floor. Well, what does that mean? Well, if the noise floor is, let's say it's 50 dB, and that's pretty high, that's higher than we want, but we may have measured or designed an unoccupied room to be at that noise level, but now we have an occupied room with rustling candy and kids being noisy and things like that. Maybe we have a 50-ish dB SPL level of noise. We want 15 dB above that. That means we want to deliver 65 dB to the listener. 65 dB, is that loud? No, it's not really. 65 dB is about the level most of us generate at 3 feet away. So if you're sitting 3 feet from someone, although it would be 6 feet these days because we're social distancing, but if we're back to the pre-social distance, we're 3 to 4 feet away, normal conversation, that's really comfortable. We can understand what we say, and even that will survive. Our speech intelligibility will be durable above an average noise floor. Now, do we need a 15 dB signal to noise ratio? No, we don't. We can still communicate with lower signal to noise ratios. We probably don't want to go down much below 6 dB as the minimum. But certainly 15 dB is adequate, and higher is better. So the other question pertaining to is it loud enough? What program material will be presented? Well, your worship surface, like the one we just examined for the sound system, music is presented. Is music going to be at 65 dB? Is that what we're going to want to present? Probably not. It's conceivable that the levels we're going to deliver to your congregation or any audience, they're going to be substantially higher than that. They may be 80 dB as an average level, and that's an average level. We want to have the sound system to have headroom for even louder sounds. We want something called headroom. So we may want another 10 to 15 dB of headroom capacity above that average of 80. So is it loud enough? Well, it will be loud enough if we can deliver the average level you want to present to your audience and deliver the headroom margin without the system breaking, distorting, sounding bad. And that would be, the qualifier for whether or not the system can be loud enough. Moving on to the next question. Can everybody hear? And so the answer to can everyone hear really comes down to, is everybody being covered by a loudspeaker? Is the speaker system delivering consistent coverage to all members of the audience, all members of the congregation? If it's not, what you're going to find is some seats are going to be better seats than other seats. As far as is it easy to design a sound system that will deliver absolute consistent coverage from front to back of the room? Sometimes it is. Sometimes systems become more complex. We need greater coverage density in order to deliver the same level to everybody. And there's a further complication in that with the further the speaker is from the furthest listener, the higher the level we need to generate at the speaker to cover that furthest listener, and that could put you into feedback. So some of these questions have, there are variables that affect other factors of sound system performance. So delivering to the answer, can everybody hear? You're going to have to look at possibly your system designer will have different system topologies in order to cover space. What I'm going to try and do is I'm going to use my my highly discounted shady camera stand. It's actually a Panavice that I'm using to grip my iPhone, so that I can use it as a camera. And let's see if I turn on my video, if we can, somebody could highlight this. And we'll see if it is.
Is Leo back?
All right. Is that visible? Readable?
Yeah.
All right, cool. So, of course, I don't know that I can really see it that well, but I don't know that I have
It's on
a...
the small screen. It's not highlighted. It's not spotlighted. I don't think.
all right.
If you drop the screen share, that'll help
Sorry.
a lot.
Yeah, drop
Oops.
the screen there.
My bad. There we go. You got it back? Okay. All right. I'm since I probably can't zoom in too far. I'm just gonna narrate a little bit. So if we're looking, don't know if my mouse cursor probably isn't visible. Oh, look at that. Beautiful.
No, it's not.
It's not. That's okay. All right. So at the top of the pictorial is side and plan views of a split array. So Marty talked about using our left and right loudspeakers in a stereo configuration. That may or may not be practical depending on whether or not the coverage of the speakers is wide enough to really allow you to pan. But certainly, if we're not doing drastic panning, doing that can be a positive effect. So we're looking at it from the top-down plan view on the right, from the side or section view from the left is a left and right array. Below that, the front section view is a left center right speaker array. Left center right. What left center right allows for is panning audio from side to side through the center of the room. It has, I think, more importance and greater applicability in theatrical productions where we want to absolutely position or localize to a person on the stage. When somebody's designing a speaker array to do left center right, you have to build arrays that have very wide coverage because you want everybody to be able to localize as well as possible to the location of the action on stage. Below that, we're showing a distributed array, and a distributed array is where perhaps you cannot cover the full depth of the room from a single speaker array. So back to if we only have a loudspeaker front and center of the room, that loudspeaker may not have the ability to generate a level at the rear of the room that's going to be equivalent to the level at the front of the room. Now we've got a large differential. We don't have even coverage. There's a big drop as we move away from the loudspeaker array. The sound level drops 6 dB for every doubling of distance. The advantage of having this distributed array is that we can more easily provide consistent coverage from front to the back of the room. And because we've added a second or third or however many loudspeakers that are delayed again back to the front for localization, we're able to deliver the needed acoustic gain because we're not having to turn the front array up so loud so as to cause feedback to the most proximate microphones, which are generally going to be right below that speaker array. So I'm now going to move my camera stand to see if we can get to the next picture. And let's see. Next time I'll try and come up with a better technical solution for sharing this video content, but sometimes you dance with the partner you brought. Figure 14-6. So this details a distributed array with a target loudspeaker. So the target loudspeaker, a target loudspeaker is not a terminology I've used before, but that loudspeaker would be a speaker that, you know, it's almost above the performance space. And what that allows you to do is localize. Your ears are going to be drawn to, your attention to the first and or loudest level you hear, right? So localization, we want to, our ear brain, the way we work, it's much easier for us to process audio psychoacoustically when the audio comes from the same direction where it's being originated. In this sequentially delayed loudspeaker array shown in figure 14.6, what's happening is that if we delay the overhead speakers, well, let's go back to, we have overhead speakers that will fill in for the level loss, the drop, as we move away from the main cluster. So we're moving back from the stage, and the sound level stays consistent because we've got the coverage from these overhead speakers. The overhead speakers are in turn delayed so that we perceive the sound coming from the target speaker. And in fact, the sound from the target speaker is going to arrive first, and the overhead speakers are progressively delayed so that we maintain that leading edge of audio from the front speaker. Next place I'm going to is another use. So imagine a theater, but it could be a large church. There are a lot of sanctuaries that have balcony seating. In this case, we have a central array shown in a section view with an under balcony distributed system. So as we move away from the stage and we're now under the balcony, what often happens is the sound from the main array is shadowed. The balcony itself, when you get far enough back, it becomes a reflector. So sound is not going to bend around the balcony. Well, low frequency sound might, if it's low frequency enough. It will bend around the balcony, but high frequencies won't. So a balcony system with distributed loudspeakers, again, they're delayed. We're going to delay so that the first arrival is always going to come from the main array. And when these are properly delayed, we lose the ability to generally recognize the speakers overheads or even on. And the reason we do is we're still perceiving the sound coming from the target speaker or stage as the source. And then I'm going to go to one last picture, and that's an exploded array versus a normal array. So I'm not gonna take a terribly deep dive here, other than to say there are multiple ways to build loudspeaker systems. This is showing a subset of them. And in this case, we're showing individual components. This is a component system. This exploded array could be full range boxes. It could be, you know, a 12 and a high frequency horn, or any one of a number of types of loudspeakers. We can build arrays that, when we say exploded, we're saying if you were to move the arc out, they're separated and they're providing coverage, overlapping coverage between the devices. And these are all methods that sound system designers have used to design and deploy sound systems for all types of scenarios, including worship. So I'm going to head back to I'm going to give actually, I'm going to leave this here. We're not going to use it at the moment, but we're going to move on to, and if we can unspotlight that, I'm going to come back over and let's share back to the questions. And hopefully I'm moving it along at a good clip for you.
Well, we're at the 2-hour mark, but
Okay.
if if you
Is
continue.
everybody okay with that? Nod your heads. Okay, cool. I wasn't looking at you. I was just going to assume you were nodding positively. I have faith. Okay. Now I got to go back and say, okay, this is cool. Now where's my slides? I don't see them here. Okay, here we are. Okay, so does the speaker system cover the entire audience? Hopefully, the need to do that is apparent. When somebody puts a speaker system in a room, we want to make sure that it's designed to cover the seats, and maybe really important to mention, we don't want to cover things. We want to cover where people are listening. We don't want to cover the ceiling. We don't want to cover the walls. It's important that we direct the energy of the speaker system towards the audience. Energy that doesn't go towards the audience and subsequently hits reflective surfaces can be it adds to essentially I'll say room reverberation. What it does is we have more reflected energy in the room, and as the ratio of reflected energy rises to get near the direct sound, what ends up happening is we destroy intelligibility. We want the direct sound to be a positive number above the reflected energy for the listeners. So the question here is, can everybody understand? So it's one thing to hear, if I do, hey, how's everybody doing today? What'd you have? Was dinner good? You probably heard me pretty well. There was audio coming out into my microphone and out of your speakers. You probably couldn't understand me very well. So the intelligibility part is a critical part of delivering audio to your audiences. And there are a number of factors that impact speech intelligibility. We've discussed acoustics, certainly loudspeaker coverage. So what are all these factors? So room acoustics, reverberation, and echo. And I'm gonna move this thing out of the way, and I'm going to do a reverberation demo because I think a lot of us people have gotten hung up on the idea that a really long reverb decay time, and reverb time is classified as the amount of time it takes for a sound to decay by 60 decibels. If the longer it takes, that decay time is a reverb time, but that doesn't, in and of itself, does not define what we hear in a room or how it acts or how it impacts things. So what I'm going to do is just a real quick a reverb demonstration, and again, I'm presenting this as anecdotal, fun, and informative, but I do want to make a point. So I have in my.
Do you want to stop sharing your screen?
Yeah, I can do that. Although, wait, weren't you the guy who says audio is better when something's shared? I'll stop sharing my screen. Sure. It probably doesn't matter for this. Okay. So what I'm going to do is, I'm kind of like tripping at the echo of what's going on screen. So I'm going to move my camera for a second just to show you what I got going here. So this is where I like record music and do Zoom stuff and play guitar and things like that. And I have a rack sitting on top of the table, and I've got a reverb unit. It's a lexicon processor. So I'm going to use that. I'm going to send my voice to the lexicon processor. I'm going to return it back to the digital mixer. So right now you're just hearing my microphone completely dry. This is just my direct sound. I'm not really looking at the meter, but I could do that just so I know where I am. What I'm going to do is I'm going to bring this up and nod your heads if you can hear reverberation right now. So I'm using a setting within the lexicon that is called a large hall. So the algorithm in this is designed to mimic the reflectivity, the decay, etc., of a large hall, and it's set to a 2-second reverb time. I'm going to push the faders up, and you should hear more reverb. So I'm going to continue pushing the fader up, and what you may be noticing is that the level of the reverb is starting to swamp out my voice. Would you say that is getting harder to understand me, maybe, because of this? Okay. So I'm going to bring this all the way down. Now I'm going to change the reverb time. I'm going to make it worse. Well, worse is relative. I mean, this really long decay time might be nice if we're doing Gregorian chants or, throat singing or something where you want to be completely enveloped. And let's stop and think about this for a second. In our sanctuaries, we do different things. So let's talk about that for a second. With speech reinforcement, to get them to maximize the speech intelligibility, we want a really high direct sound and we want a really low reverberant sound, right? How does that work for things like choir singing? Not that well. Why? Well, because as there's more direct and less reverberant, people start to get self-conscious about hearing them, selves kind of sticking out. So for congregational singing, having a higher reverberation time helps people's confidence, helps them, sing at a decent level. It makes music sound subjectively better. Reverberation enhances it. It can, sort of
covers mistakes.
What's that? Well, yeah,
it also covers mistakes.
I guess you could say that. I don't think I've ever used reverb to cover mistakes, but at any rate, reverb is it's kind of like seasoning to your food, right? Just the right amount is fabulous. And if there's too much seasoning, it's not good. It's not appetizing anymore. So,
it's
having
the beauty
said that,
filter of sound.
What's that?
It's the camera filter, the Snapchat filter of sound.
There you go. I like that. I hadn't thought of that ever before in my life, and now I will remember that forever. Okay, I accidentally changed.
When you need another shot from your Spice Weasel.
My Spice Weasel. Okay, so I'm back to a large hall, and I'm going to hit load, and now I'm going to go to my reverb time, and I'm going to take it up to. I'm taking it up to 3 seconds. 1, 2, 3, 4, 5. Now, I'm going to keep talking. I'm going to increase the reverb time.
That kind of sounds like the National Gallery, the National Cathedral.
Yes. Now I'm going to bring the reverb level down. 1, 2, 3, 4. So here's a question. Am I intelligible? Can you understand me? Even though you're hearing a long decay?
Yep.
Yeah, reasonably well.
Okay. So I think what I want to just simply convey is it's not that the reverb time in and of itself is the big bugaboo. It's that it's the ratio, right? Direct to reverberant. So a long reverb time, we can deliver intelligibility as long as we can keep the direct sound above. And in cases like that, we generally, audio engineers, will build loudspeaker arrays and use speakers that have really high directivity. What does that mean? They concentrate their output and control it and confine it into smaller areas. So instead of maybe using a loudspeaker, I'll just throw a common speaker, 120 degree by 60 degree coverage, you put something that has that has little directivity control. We're putting energy everywhere. Energy that goes everywhere helps contribute to the reverberant field. And when we focus and concentrate and steer it towards the audience, and people, you'll hate me for saying this, it's absorption. People suck because they absorb. Our bodies are absorbers. Our clothes are absorbers. If we sit on padded seats, when we leave the seats absorb. we really want to make sure that that our sound system is only putting sound where we want it and need it. And in fact, if you have a smaller audience and you have supplemental speakers, remember the delayed array, right? You could, if you don't need it, turn it off, because anything that's, you know, all these speakers do tend to contribute to the reverberant level. So back to the PowerPoint. Is the slide still visible, or do I need to hit share again?
It needs to be
Go ahead and share
Okay,
it.
hit and share again. So reverberation is a thing. There's another thing that can be an impediment, and that's echo. So what you're now hearing is I've got an additional delay on my voice. So you're hearing both the direct and the delay. I'm hearing direct and delay in my headphones. It's driving me crazy. When you have a long delay, what ends up happening is you have a hard time concentrating on your own voice. So the delay time, let me jump over here to my my board. I'm using the internal effects processor on my board. That's a 200 millisecond delay. Now, let me talk a little bit about the speed or of sound, right? Speed of sound is pretty much a constant. It varies a little bit depending on temperature, but it's about, I want to say 1,130 feet per second. So, you know, doing a little math, we can get to sound travels about 1.13 feet in a second. Or I'm sorry, 1,130 feet in
Every millisecond.
Yeah, so in a millisecond, it's 1.13. A 200 millisecond delay would kind of equate to I'm standing on a stage and there's a hard wall 100 feet away, and now I'm hearing a large return come back. Now, would I hear a really, really large return? Depends. What if the back wall is curved and now I've got this reflector really coming back? So I've been in places that have had hard back walls where it made it very difficult for people on stage to be able to communicate. It made it hard to play music. Do the acoustics affect speech quality and intelligibility? Yeah, they certainly do, and we're hearing that. I'm going to drop the delay down because it's not just a really long delay that can be troubling. I should mention you could also have shorter delays at high levels. What I'm going to do is come back over here and to my return. 1, 2, 3, 4. Okay, I've dropped that delay about in half. We're only hearing one return. In a lot of cases, you're going to hear multiple returns. I can change this. So that's 100 milliseconds. I'm 50 feet from the back wall. Now what I'm going to do is I'm going to add some feedback gain. 1, 2, 3, 4. Now you're hearing multiples, right? Flutter echo, right? You've been in rooms probably where if you clap your hands, you can hear the sound going side to side. So I just, my goal here is to try and convey.
I've been in rooms just like that.
Sure, right? These are things that affect what we hear, how we perceive, how we deliver speech, whether or not it's going to be intelligible, whether it's going to be enjoyable. So
in fact, one room, if I could highlight this.
Yeah.
So the loudspeakers were on stands, so they were parallel to the floor, right in front of the stage.
Okay.
Now, the wall opposite the stage is about 60 feet away, and it's all a hard surface. In fact, much of the surface is hard wood surface. So that bounces back to the stage. Now, behind the stage is all glass.
Right.
Flat glass. So the sound comes out of the speakers, bounces off the back wall, comes back, bounces off the wall behind the stage, and then gets into the microphones.
That's
Tough
not good.
position.
Yeah. Well, you know, so that's interesting. That's a great point. So, the microphones on stage. You know, again, if somebody microphones on stage pick up everything that's on stage. It's kind of indisputable that they do. So when somebody's not in front of a microphone singing, what should you do with that microphone input? You should turn it down or mute it. I don't know if anybody's ever mixed sound. They've had a row of vocal microphones in front of a drum kit and cymbals. Cymbals, even if you have barriers in front of cymbals, cymbals are evil. They will bleed into your vocal mics. They'll bleed into everything. I want to move to the next bullet.
Tambourines too, right?
What's that?
Tambourines too will bleed everywhere.
Yeah, high thing. Musical instruments that produce high frequency sound tend to go everywhere.
Especially high frequency percussive sounds.
Yes, thank you indeed very much. So signal noise ratio. So we talked about, we demonstrated the measurement of noise. We didn't really demonstrate the impact of noise. I don't know how effectively I could do that because we have a noise canceller in Zoom that we cannot defeat. So that noise canceller you have when you're in original sound, we've got 3 settings for it, I think, low, medium, high, something like that.
You can defeat it in original sound. You got to go into your settings to do it.
Are you sure? I didn't think you could defeat it. I think you could set the noise canceller to a very low setting. But what I could do right now is just come over here to my utility page, and I'm going to go to pink noise, and hopefully I won't blow my ears out when I do this. Let's see if I can send...
In the advanced setting, you can disable noise cancellation with original sound.
All right, cool.
This is the time those of us wearing in-ears should take them out.
All right. Okay, so I'm also going to send this. Are you hearing?
Yeah, we hear it.
You're hearing it now. I'm going to put it in my stereo bus so I can hear it. And now I'm going to come back over to level, and I'm going to increase the noise. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I may be driving you all crazy. I'm sorry about that one too. All right, that's enough with that. So that's noise floor.
But even low-level noise, hurts your intelligibility.
Well, so here's something to just consider about what I just played. That was full bandwidth pink noise, right? So 20 hertz to 20 kilohertz. Noise from like an air conditioning system. Remember what we're getting when we looked at that curve. Generally, we're not getting a lot of high frequency noise from air conditioners. If we did, we'd be walking around with either ice picks or earplugs for our ears all day long. But I'm just to the point. Noise will impact our ability to perceive intelligible speech, for us to have intelligibility. And when you lose intelligibility, it's like, why are you there? We're here to hear a message. We're here to communicate verbally with each other, to enjoy music, etc. Distortion, distortion can impact intelligibility and frequency linearity as well. So I've got one more thing I can do in the demo side of things. What I'm going to do is I'm going to go to my parametric equalizer. And I am going to put in a 2-octave cut. I'm going to take this down to about 3 kilohertz. And
I want the Beatles' Uncle Albert.
1, 2, 3, 4, 5, 6. Have you heard a change to my audio quality? Yeah.
What did you cut, Jay?
Is it pretty? 1, 2, 3, 4, 5, 6, 7, 8. So this is not a digital device. So my frequency was centered at about 3 kilohertz, and it was a 2-octave wide cut, and I cut it pretty drastically, 15 dB. So I think the point I want to make, or I could just simply come over to I have a low pass filter on this. I can take my low pass filter and do the same thing. My low pass filter, is it in or out? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8.
It's not enabled.
It wasn't enabled. Let's see. Input output meter.
The all important
Pre-post. Here we go. Let's try that again. 1, 2, 3, 4, 5, 6. You're hearing it now, aren't you?
Yep. Yeah, we are.
1, 2. So now I'm going to bring that low pass filter. So I'm going to sweep this and tell me when you hear it working. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19,
Nope.
20. Hearing it now?
Nope.
What are we listening for?
21, 22, 23, 24, 25, 26, 27, 28, 29,
Starting to
30.
get fuzzy.
Okay, now it's starting to get fuzzy.
You're sweeping a notch cut.
Yeah, I'm sweeping the low pass filter down. Actually, this low pass, I don't know if I believe it. It says when it's all the way fully clockwise, it's at 40 kilohertz. Now it's at 12 kilohertz. Now it's at about 7 kilohertz.
Yeah, we hear that.
All right, now I'm going to take it out of circuit. It's out of circuit. It's in circuit. Out, in. Okay. So frequency linearity. It's high pass, low pass. Are we getting the full bandwidth? And the linearity part would be, frequencies boost or cut to, particularly if they impact the critical bands for speech intelligibility. 2 kilohertz is probably the most critical band to human speech. Next question, will it feed back? So we talked a little bit about acoustic gain. What does acoustic gain mean? So potential acoustic gain is the maximum gain you can achieve turning the microphone up in the room with a loudspeaker until the point it starts to feedback, where you start getting loop gain, then backing it down 6 dB. That's probably with a single open mic. That's your maximum potential acoustic gain. If you leave the microphone at that level and don't touch the fader, it won't feed back. That's as loud as you can get. If you were to open up a channel for a second microphone, with 2 open microphones, the gain figure is cut in half. So doubling the number of open microphones reduces available gain 6 dB. And we've had past discussions about automatic mic mixers, which manage the gain so that you can't have 2, 3, 4, etc. microphones open at the same level, giving you feedback. So one way to manage gain is to manage the number of open microphones. Another way to manage the acoustic gain is shortening the distance between the loudspeakers and the listeners. That way the loudspeakers don't have to rise to that level and then contributing to feedback. Moving microphones closer to the talker. So if the microphone, you're using a head-worn microphone like Mark is using right now, and that's live in the sound system, I can get the most gain, acoustic gain, out of a talker using a head-worn mic because the mic's close to their mouth. I don't have to raise the level. So the type of mic, the number of microphones, the frequency response of the microphone, equalization, the sound system, those things impact the amount of acoustic gain you can deliver. You need to deliver enough acoustic gain to, deliver the headroom level without distorting the system. So again, these things are interdependent. Speaker design, microphone selection, system equalization, number of open microphones, all these things work together. Okay, the 5th question, does it sound good? So, the answer to that is subjective. Does it sound good to you? Does it sound good to me? What qualifies something as sounding good to you, to any of us? We may not always agree on what sounds good or what sounds bad. I've got a bunch of acoustic guitars behind me. I can pick any one of them up. Even if I have 2 guitars, the exact same manufacturer, built the same day, they're going to sound slightly different. I'm going to perceive that. All of us have different factors that affect our perception of sound. Some of them might be physical. Maybe we have a hearing impairment, right? I know I've got impaired hearing. One ear's just substantially worse than the other ear in terms of high frequency loss. I have preferences in what I hear. And depending on my mood, depending on, did I have caffeine? There are a lot of different things that affect sound perception. We probably would find, that there's wide agreement. I like Mark, I mix shows, mixed live sound for performances for, my entire career on and off. I generally, when I'm mixing a show, very rarely will somebody come up to me and say, it really didn't sound very good. Generally, people say, wow, it sounded great show. Maybe what do I take from that? Not that I'm, not that I'm the greatest sound engineer, but what I perceive and what I like is generally something that matches the audience's expectations of what they hear. So the answer to what sounds good is subjective, but the factors that can negatively impact sound quality are often objectively measured. Distortion can be objectively measured. Frequency response objectively measured. We can, measure delay. We can measure, direct to reverberant ratios. There are a lot of things that we can quantify and qualify scientifically. But even if, the meter says, hey, it sounds good, could it sound bad to you or somebody? Yeah, maybe we're not measuring the right thing. The answer is, can we build sound systems, tune them, deliver them to so that the vast majority of people who come into the venue believe they're getting good sound? We absolutely can. Can you please all the people all the time? No, you can't. If something is described to you as bad, the onus is on us to go take the steps to quantify, measure, find out, get their description, and then see if we can find out what is what their perceptions are telling them, and is there a physical something that we can measure that has an effect.
Now,
So,
if I could interject,
please.
part of the mixing course that I teach, I talk about the responsibility of the sound person. Well, the last mile in mixing is really you at the console and what you're doing with
True.
the tools you have available to you to correct problems you may be hearing. Like
Mhm.
the artist just moved away from the microphone or accidentally turned their guitar up or down,
Right.
things like that. One of the things that I do to make sure that I'm on the right track is I always try and find somebody sitting near me whose ears I trust and periodically say,
Yes.
how does that sound to you? And they might say, gee, I'm having a little trouble hearing Linda's vocals. Oh,
Right.
you know something, now that I listen carefully, you're right. She's a little in the background. Let me boost Linda. Having somebody whose opinion you trust nearby, ask them.
Right.
Don't immediately think you know everything and that you've got the perfect mix.
Yeah.
Seek
But if it's the lead
out other
singer's
things.
boyfriend, you take it with a grain of salt.
Well, there's always that, yes. Consider the source in
Right.
all of these.
Wife, whatever. No. No, absolutely true. And likewise, I check with other people. I also, I walk around the room during a performance. Sometimes I go take different seats during a service. Just, again, when you're back in a sound booth, you're not hearing what your audience is hearing. Congregation is your audience. We want to deliver the best quality to the people who pay for everything to happen, who come to the who are members of the congregation and contribute and nurture. Our goal, if we're in a technical role, is to make sure that we're delivering every day. So I bet you're all going to be happy to know that this is my last PowerPoint slide. You may rejoice. So why doesn't it sound good? Could be distortion, frequency level imbalances, could be problems with the source or program. I mean, if you play a crappy source and your sound system does a good job of amplifying a crappy source, people may perceive it as a system problem. May not be a system problem. It could be a source problem. Source problem could be
Hard to
somebody who
start
doesn't
out.
articulate when they speak, somebody who's really quiet when they speak, somebody who's on the microphone and yelling into it when they speak. So it may not be the system, but people are almost always going to blame the sound system because it's easy to blame the sound system. And on that note, I am done. And then if there are any questions on any of this, I'm happy to take them.
I think it's probably an appropriate time to open the microphone since we only have 22 people here right now.
Okay.
Might be a
21.
good time to let people talk and ask their questions that way.
Before we do that, Marty, do we want to just wrap up the YouTube
Recording?
part?
Can't hear you, Marty.
The YouTube stream.
That would
Did it to himself again.
We lost
I
Marty.
think
He must
said
be a
that would
sound guy. He
good.
keeps muting himself. Yeah.
Here we go.
He said that would go. Okay.
Well, that was interesting. I mean, that was a lot of fun. Thank you, Jay. That was
pleasure.
very comprehensive. It was deep,
Fun.
and it's something that we all of us who look at rooms and envision how we're going to cover sound in a room, how we're going to create a sound system for a room. Every room is different. Every room is a challenge. We have to think about all of these different things that you talked about every time we go into a different room. And, and for those of us like you and I and people here on the panel and others, even if we're not going into a room to do a room, anytime I walk into a room, I'm mentally going through it myself. It's like, once you know this stuff, you can't unknow it. So
It ruins going to concerts for you.
I work
once it
hard
makes-
to try and enjoy the performance and not pay attention to the technology. I think I've learned to do that pretty well over the years.
Yeah.
Sometimes
I've actually got, so for people who are still with us, I've actually got a quick case study in pictures that I'll talk about in the post show about a room that I did that was a challenge and worked out well. Pretty simple to understand because of the pictures, so hang around for that.
Hey, and you know what? I think I would be doing a disservice if I don't mention the paid, the text that I used with my my soldering buddy camera stand. This book is Audio Engineering for Sound Reinforcement by John Ergel and Chris Forman, both of whom were with JBL. John was an absolutely brilliant man. Unfortunately, he passed some years back. Fortunate to have met him at one of JBL's. They did this engineering conference I went to in year 2000. They funded, couple hundred people maybe to come out to LA and spend 3 days at the factory and, hear technology, hear people expound on, papers and things. This is a fabulous book. I have a big library of audio books. I'd be happy to catalog what I have and drop those in the Discord. So if you're interested in following up and reading these texts, they've immeasurably helped me be able to do what I do in audio.
More books are always better.
Yeah.
I love books.
And that's a great one. That's like the Bible of acoustics.
It's one of them. Audio Cyclopedia, Sound System Engineering, and then there's and I'm blanking on the book by a guy with Meyer Sound who developed SIM technology. I've got a library full, and that's where I go first before Google is a last resort when. With audio questions, even though, some of the technology in some of these books is dated, the audio fundamentals, the physics have remained the same.
All right. Well, great. Thank you, Jay. That was really, really, really complex. I mean, and you made it easy to understand, too. There's a lot to it. So that's it then for this show. I'd like to thank all our panelists and our guests for a really, really very, very interesting conversation. We all hope that you've enjoyed our time together. Perhaps you found it informative, enlightening, enriching, energizing, and motivating. Watch the Discord for upcoming shows where you can find recordings of past shows to review, announcements about upcoming events, and our third needs assessment is coming up for the larger church. For next week, topics are still up in the air. Now, if you got the weekly email this morning, there's a list of topics that I highlighted that I was supposed to put in the poll, but didn't get to it. Let us know which one really interests you, and we'll try and put that together. So, and for most of us, this is all this technology, streaming services. This is all brand new stuff that we're all figuring out together. Many of us for the very first time. So, the field is wide open. Make it your own. Reinvent your ministries. Think bigger about your communities and how you can reach them. Dare to dream. We'll see you all next week. Thank you.